Yeah, so I'm gonna keep recording if that's all right with you guys. Um, I just figured that not everyone can make it at this time, so um, we'll try to make it just available for everybody. Um, as for this Wednesday group in particular, the way that 10A was structured beforehand was um, just one meeting a week for 10 weeks. So that's kind of how I prepared my notes last fall when I first started. And that's how they're still organized. So um, with that being said, I sent out an email, which is hopefully you guys were able to read it. If not, that's fine. It wasn't too important. But what I'm gonna try to do is keep my Monday lectures more conceptual in nature. So kind of like what we did this past Monday. And then on Wednesdays, we're gonna just go over some practice problems that apply to what we went over.
Presidential election winner in 2000, 2004, 2008, 2012, 2016.
But yeah, so with that being said, I was probably just going to cover maybe the extra problem set, just because there's not a ton of material that you guys are expected to know at this point. I think that once we start moving into next week and then week 3 is when it really picks up. Then we'll probably have like midterms that we can work off of. But yeah, for now, just the extra problem sets. You guys did have a homework problem set that I believe there's a video for on Gaucho Space with explanations. So hopefully that kind of covers that. But are there any questions about problem set 1? I can try my hand and see if I can answer them. But if not, yeah, as I mentioned before, coupons. Yeah, I'll try to go over coupons. Is there a particular question that you had on coupons? Were coupons on problem set 1? Like a particular question there? Not particular. Yeah, it's fine. I'll just kind of quickly go over it since it was in my Monday video, and so if you really are interested in kind of getting a more in-depth idea about coupons, you can definitely check it out there. But yeah, with coupons, essentially coupons, you can kind of think of them as like additions to what you can consume. So it kind of depends on what your coupon is, right? Whether it's like a free coupon or whether it's like a 50% off coupon, right? But essentially, when you look at coupons and how they, do you mind muting yourself if you're, or just check to see if you're muted? But essentially with coupons, right? If you look at your budget constraint on your X1, X2 axis, here, hold on, let me try to mute this person. Huh. Oh well. But if you look at coupons on how they fit on this X1, X2 axis, right? Say that you're dealing with, say, P1 is equal to 5, P2 is equal to 10, and M is equal to 60. So this was the example that we used last class, right? And say that we're given 8 coupons of 1 free unit of X1, right? And so in this case, notice how there's no changes in prices or anything, right? This is going to be important when it comes to analyzing how the budget constraint is affected. So if we look at our original budget constraint, we'll see that we can originally buy 6 units of X2 and we can buy 12 units of X1, right? And so we previously had something that looked like this with a slope of -1/2, right? Where P1 over P2 was just 5 over 10. Now, if I'm given these 8 free coupons, and this is all the information I'm given, right? You want to look at how this affects your consumption of X1 when you're only buying X1, and how it I mean, yeah, it effectively is changing your income, just not with like a monetary sense. It's more of like a purchasing power sense. But yeah, it's very similar. You want to think about it as almost like a change in income, except for the fact that when you're only consuming X2, right, you're not going to be able to afford more X2 because of these coupons, right? Unless you're able to sell those, which is what I'm going to get into in the next problem. But looking at how X1 is changed, you can now afford 8 more units, right? So that takes us from 12 to 20, right? But you don't want to connect it from here to here. You also want to think, well, when I'm only buying X2, right? Um, that means that I can afford 6 units of X2. But at the same time, I can still use those coupons and get 8 free units of X1. So that's why we're going to have a point right over here, right? And these are parallel lines. However, you'll notice that when you change your income, typically what happens with the budget constraint is that it totally shifts out to where you would have something like this. But with these coupons that you can't resell, right, you're not going to be able to do that, right? Because this point right here just simply doesn't exist. Now, going back to my example yesterday, where you can sell your coupons for $5, right? You want to kind of think about with and without the coupons. Yeah, so this is without the coupons, and this is with the coupons, just to answer your question. And maybe I can use a different color for this next example. But let's say that you have this ability to sell your coupons for $5. What I like to do is I like to immediately kind of assume that you do sell them, right? And because you have 8 of them, your income goes up by $40, right? And so now you can kind of do the same exact thing where when you have 60 plus 40, right? So you now have M is equal to $100, right? Hopefully you guys are still following with that. Now you're still able to buy 20 units of X1. That doesn't change, right? So remember, this axis is M over P1, and this axis is M over P2. However, now because of the income being changed, right, you're going to be able to afford 10 units, right, of X2 now. And so you now have this whole portion of the budget constraint as well as this portion right here. So just to kind of recap, this portion right here is the budget constraint with coupons, but you can't sell them, right? However, this whole portion right here is the budget constraint with the ability to sell your coupons. Does that kind of answer your question about coupons? I forgot who originally asked it. But yeah, Victor, hopefully that answers your question. And so for Brandon, yeah, it's a shift, not a pivot, right? That's a really important concept because of the fact that if you kind of just analyze what the information gave you, there was no single price change, which means that the slope of your budget constraint is just going to stay constant, right? You're not going to get a different slope. It doesn't change the equation or anything. It's kind of hard to factor this in to the equation. If I'm just kind of trying to think about it. But this is how I would treat coupons. There's nothing like too fancy about it. It's not necessarily mathematical in nature. It's more just kind of just conceptual, if you will, right? So this is kind of my recap about coupons. I saw something about tiered pricing. Is that something that you still want me to go over? And keep in mind, these concepts are all in the video that I posted on the Gaucho space, so it should be there. And here, if you want me to do it real quick, I could, or else I'm just gonna get into practice problems. So actually, I can maybe just do something real quick with it. So tiered pricing, do you mean that in respect to the sales tax, or do you want it with respect to you can buy like 4 for this price, but then any unit past 4, it's a different price? I think that, yeah, okay, that makes sense, and that's actually kind of a fairly nuanced concept that doesn't really appear a lot, but can be a little tricky. So let's go back to this x1, x2 scenario, right? This is tiered pricing. And we're still going to have the same scenario where P1 is equal to 5, P2 is equal to 10, and M is equal to 60, right? And we're going to say that the first 4 units of X1 equals $5, and then anything past 4 units of X1 is equal to $10, right? And so I mentioned this in the past lecture, but the way that I like to analyze these kind of tiered pricing questions is I like to think about 3 different scenarios. I like to think about the scenario where you're only buying X1, right? So you're finding the axis here. I like to find the scenario where you're only buying X2, right? And in most cases with the budget constraint, you're going to be able to just make this linear like line that connects the 2 axes. However, with tiered pricing, there's a third point that you want to be familiar with, and that's like the point at which the price changes, okay? You're going to want to see what happens when I'm buying 4 units of X1, and then the rest of my money is going towards X2, okay? And so if we do these steps, right, so let's do step 1. If I buy my first 4 units for $5, right, that is $20 for 4 units, right? And now I have $40 left because I start off with 60. So here, maybe that's not really clear. So I now have $60 minus 20 equals $40, right? And now, because I'm still insisting that I buy only X1 because I want to find that axis, right? I have to divide by the new price, which is $10. And now I get 4 units, right, for 40. So notice that the entirety of my income has been spent, and I now have 4 plus 4 equals 8 units of X1, okay? So I'm gonna draw this axis right here as 8 units, and our X2 is still just gonna be the same because none of this tiered pricing information relates to X2 in any way. And so my X2 is still gonna stay at 6. Hopefully everybody can kind of follow with that. Now, looking at this third point, right, you wanna, as I mentioned before, analyze where the price changes. And so this point, right, is gonna make the assumption that I'm buying 4 units of X1. So let's already just kind of draw this. We're gonna have our point be somewhere along this kind of line that goes straight upwards from 4 units of X1. Now, when I buy these 4 units of X1, right, remember that's $20 that is now allocated towards X1, but I want to see how much of X2 I can afford to buy, right, given that I've bought 4 units of X1 already, right? So we still are going to have $40 left, but now because I'm buying X2, the price is $10, which is going to mean I can buy 4 units of X2, which is going to put us at this point right here, right? And notice how in most cases, right, as I mentioned before, you would be able to kind of just draw this line that connects. But notice how this point right here is not anywhere on this line, right? We actually have this new budget constraint that looks something like this, where it connects here and then it goes down like that, right? And so we call this the kink point. And I'm fairly sure that in any scenario in which you have this tiered pricing, you're going to end up with these king points. Does that kind of answer your question about tiered pricing? Just leave it in the chat. Yeah, the point where P changes is the king point. So notice how this king point right here is 4, comma 4, which means that I have 4 units of x1.
Like we finally learned how to use this. Yeah, because the chip is broken. Yeah.
I got it. All right. So essentially what this point is right here is 4, 4, right? And the significance of 4, 4 being the king point is that this is where the price changes, right? It goes from $5 to $10, right? And that's kind of the significance, right, of this 4, 4. So hopefully that answers your question about that. I'm now going to move on to the extra problem sets. Unless somebody has questions about the homework, which is just like the regular problem sets. So you would do the exact same thing to answer your question, Justin. You would basically buy up to that amount and then see what happens when the rest of it is allocated to towards the other good. It'd be a very exact process, right? So don't necessarily think about the numbers that I used. Think about the process that I took, right? Where I only bought X1, I only bought X2, and then I bought X1 up until the price changes. It doesn't matter in which direction it changes. It only matters that it changes. And then find how much of X2 I can buy, given that I've allocated this much money towards X1, right? So you got to find your 3 different points. And so to answer your question, Sienna, I was going to do the extra problem set number 2, just because there's no extra problem set number 1. And what else? I could answer specific questions about problem set number 1, but I wasn't going to do the whole thing just because there's already a video from one of your TAs about it. So I'll give you guys maybe like 20 seconds while I just drink some water to maybe list specific problems in problem set 1 that you want me to ask or to answer. And if there's none of those, then I will just kind of go on to what I originally planned to do. All right. It looks like you guys are all set on problem set 1, which is good. I would definitely recommend just being familiar with that kind of the way that the problems are asked is very similar to how you'll see it on a test. So it's kind of good to be familiar with the structure, right? But also just be familiar with the material, I guess is probably the most important part. So with that being said, let's do extra problem set 2. You guys can feel free to open this on your guys' laptops. I would share my screen, but when I share my screen, it makes my window a lot smaller, and so it becomes harder to see the work that I'm actually doing. So you guys should definitely open up extra problem set 2. I'll give you guys maybe another like 20 seconds to do that, and then we're just going to go ahead and get started and work right through until the end of time. Yeah, so Victor, to answer your question, there will be stuff that you guys haven't necessarily covered yet, at least in my group. I'm very cognizant of that. So I'll make sure that I don't leave you guys more confused than you guys came in, but there will be some stuff that you guys haven't touched, and I kind of acknowledge that.
Wait, are we working through the problem set, or what were we working through? Sorry, I blanked.
It's
What
extra
happened?
problem set 2. The extra problem sets, not the problem sets.
Is it on our site or is it on yours? Like on Gotcha?
Well, it's on your Gotcha space. It's on our it's on the Econ 10A Gotcha space,
Not the class one.
not the CLES one. No,
Oh,
it's on
okay.
your guys' home Gotcha space for the class.
Oh, okay, sorry. Okay, thanks.
No worries. And yeah, as I mentioned before, there will be some material that you guys you know, haven't really had the opportunity to fully learn yet. And you know, I think that's all right. It'll be a good introduction, right? Because these problems are intended to be a little bit easier, just in terms of like the complexity of the problem itself. But concept-wise, it's a really good introduction, I think. So let me kind of just work through it. Hopefully everybody has it open yet already. And so yeah, let's get straight into it. So we are doing extra problem set 2, and let's go over question 1. So before we kind of answer question 1, I want to first talk about the idea of preferences, right? And how they match up against the budget constraint. So in this past group that I had on Monday, we talked about how the budget constraint was what you could afford, right? But we made no mention of what we actually wanted, right? So what we want and what we can afford are two different things. And the key point of this class is optimizing what we want based on what we can have, right? And so that's where preferences come into play, right? We are gonna have these kind of notions of preferences, how you know, we have some goods that we consider, or we have some objects that we can consume that we're gonna call goods. There's gonna be some that are called bads, right? Goods are things that you always are gonna want more of. So I think that you guys have probably been introduced to the concept of monotonicity, right? Which is basically saying that more is better if something is a good, right? You're always going to want to have more of something that provides you with this concept of marginal utility. So if you kind of go back to what we talked about with utility, I just briefly mentioned it, right? But marginal utility is this concept of, well, actually, first, before we talk about marginal utility, talk about utility, right? Utility is like this general measurement of happiness. It's kind of just a theoretical thing because everybody's happiness is kind of subject to their own personal like beliefs, how like they value things, right? So utility for one person is way different than utility for someone else, right? Marginal utility kind of it covers what the increase or what the decrease in a person's utility is from adding one single unit of another good, right? So let's say that I have 5 units. So this is x1, and then this is utility, right? Let's say that I have 5 units and I currently have 10 units of utility. If I go to 6 units and my utility goes to 12, then my marginal utility at this point right here, right, is going to be 2 units, right? And as you guys are going to learn, there's going to be a mathematical way of interpreting our marginal utility. But this is kind of just like this brief introduction that hopefully kind of gets you guys thinking about what being on the margins looks like, right? So with that kind of being said, and also if you guys are still a little bit confused about this, don't worry at all. I'm going to make sure that I cover all of this next Monday. But you know, I have to cover something, I guess, for this class. So going over question 1, right, we're going to say that Levi's preferences are defined over left shoes and right shoes, right? And this is like the perfect example of what we call complements, right? Where complements are two goods that you usually consume in tandem with each other. So you're not going to have a left shoe and just not wear a right shoe, right? similarly, it doesn't make sense to have 5 left shoes and 2 right shoes because you can only make 2 pairs of shoes out of those, right? So it's kind of that thinking. It's like hot dogs and hot dog buns. Trying to think
Could
of,
you actually say the whole shoe thing though? Because shoes aren't sold separately. At least most shoes aren't.
yeah, so you would kind of make the assumption, right, that in this case, shoes are sold separately. And
Gotcha.
so
Okay.
that's why it doesn't make sense to buy like 5 left shoes or 2 right shoes, right?
Yeah,
Uh,
I understand that part.
yeah, so I get what you mean because I guess companies kind of acknowledge the fact that you're not going to want to buy shoes separately, right? And so
Yeah,
that's why
that'd
they
be
sell them together.
crazy.
But in this scenario, right, that we're kind of taking a more theoretical look at it, right? You imagine that you can buy them separately, right?
Hmm.
So
Something like peanut butter and jelly, maybe.
exactly, right? Just you guys can probably think of a whole list of that. Now, the goal of these complements, right? And so kind of go along with that, we call a certain kind of goods perfect complements when they're like completely tied together. So like left shoes and right shoes, for example. Whereas other goods are complements, but they're maybe not as tied to each other. So you can maybe think of like um, soda and ice cream, right? They're somewhat similar because maybe you want to make a root beer float, but they're not that tied together. So those would just be like looser complements. But that's kind of just looking forward into things. So with left shoes and right shoes, we want to think about what a possible utility function is. And so to kind of, yeah, I feel like we're really just going into next week's lecture, but to kind of explain what a utility function is, right? Remember how I said that utility is basically just this measurement of happiness, right? And so when you think about the bundles that we have, right, which is basically just a combination of x1 and that's not showing up well. So when we have these bundles, which are just a combination, which are just a combination of x1 and x2, right? These are our bundles. These are what we call inputs that produce our level of utility, right? So if we have utility of x1 and x2, right, these are kind of the inputs or parameters that we're going to use. And this is equal to x1 plus x2, for example. Then say that I have 5 units of x1 and I have 2 units of x2, right? This is going to be equal to 5 plus 2 is equal to 7, right? And this is just an example of a utility function, right? And so I'm going to actually let you guys kind of think about what a good utility function for this example of preferences would be, right? I'll give you guys maybe 20 seconds, and if anybody has the answer, feel free to just shout it out or leave it in the chat. But yeah, I'm gonna leave that to you guys. And maybe you guys have already kind of covered it. I haven't really been watching your guys' lectures. But yeah, 20 seconds. And when you're thinking about a utility function, think about what I said, that it makes no sense to have 5 left if you only have 2 right, right? And it looks like Connor typed something in that is exactly on point with what I'm looking for. So what Connor said was a utility function that would fit these kind of preferences would be utility, right, of the so utility as a function of x1 and x2 is equal to the min of x1 and x2. And I want you guys to kind of think about why it's going to be a min function, right? The reason why it's a min function is because, like I said before, if I have 5 pairs, or if I have 5 left shoes and I have 2 right shoes, right? The most that I can do with this is make 2 pairs of shoes, right? And so that's why this is going to be equal to 2, right? Because although I have 5 units of left, I only have 2 units of right, and that's kind of what's holding me down, right? And it actually doesn't make sense to have 5 left and 2 right because of the fact that these extra 3 units that are unnecessary, they still cost me money, right? And so I'm basically spending money for nothing. So you want to basically have it to where these 2 numbers are either the same, right? Or they're as close to being the same as possible, right? You basically want to set x1 equal to x2, right? For the most part, right? And there are cases in which you maybe have something like 2. Yeah, that's not clear. There may be cases in which you have something that looks like 2x1 comma x2, and in that case, you would basically just find x1 as a function of x2. But that's moving forward a little bit. And also, I really apologize for how slow I'm taking or how long I'm taking to kind of get through these questions. But I want to make sure that you guys have an understanding of what's going on before we actually kind of get to it. So as Connor said, the utility function is the min of x1 and x2, right? And so let's kind of plot what 3, 2 looks like with respect to the indifference curves, which is another topic that we will later cover. But yeah, so I have x1 here, I have x2 here, right? And I have these indifference curves that with the min function, you'll see they look like these L-shaped things, right? Because basically, say this is the 0.11, right? Kind of the same thinking. You don't get any other benefit from being here, right? Where this is like, say, this is like 1.5, right? Right? You're still only going to get 1 utility out of that. So that's why we have these L-shaped things. Now, the 0.32, right? So let's first go to 2.2. Okay, like this. The 0.32 is going to be right here, right? And I'm basically just going to see that I'm on this indifference curve, right? Meaning I'm only going to be getting 2 utility out of that. And hopefully you guys can see that the min of 3, 2 is still equal to 2, right? And so what this point here, right, is essentially just describing a point that really isn't very useful, if kind of you want to think about it that way. Marginal rate of substitution, I think we're going to wait until next lecture to kind of get to that because it is kind of a heavy topic. But if you guys know the answer, that's even more power to you. So I'll just kind of leave that to you guys. But this is how I would kind of approach, like for the most part, this question. It's okay to maybe not understand it. I think that all in all, this is kind of just good exposure to you guys. But yeah, let's move on to question 2. So looking at question 2, the description is a consumer faces prices and income 6,324. So P1 is equal to 6, P2 is equal to 3, and M is equal to 24. And he comes back to the market having chosen 3 and 2, right? So let's kind of think about, first off, let's draw our budget constraint. I think that's always a good way to start. So we know that this intercept is M over P1, which is basically just going to be 4. And this is M over P2, which is just going to be 8, right? And just like that, we have a slope of negative P1 over P2, which is just 2, negative 2, I guess. And so he comes back to the market having chosen the point 3 and 2, right? Meaning that he bought 3 units of good 1 and 2 units of good 2, right? So he's right here. And that means that $18 and $6 were allocated respectively. Now you offer him 3 units of good 2 if he'll give you 1 unit of good 1, right? And so you kind of want to think about, actually, is this a good question to ask? I'm just going to cover this, and it's possible that you might be a little bit confused. And then I'm going to check the chat and see what the points of confusion are. But hopefully, as I'm doing it, you'll be able to kind of see what I'm doing and see what the logic is behind that. So you offer him 3 units of X1 for 2 units of X2, right? With 3 units of X2, sorry, that's just not reading the question correctly. And he'll give you 1 unit of good 1, right? Would the consumer accept this offer, right? And you kind of have to think about what this right entails. So let's take a look at what kind of is going on here. We know that essentially, all right, so essentially based on what this consumer preferences are, right? He willingly went to the market and he chose this point right here, right? And the fact that he has strictly convex indifference curves is something that you'll kind of soon later learn about. But it basically means that he has an indifference curve that looks like this, right? And just like a quick summary about indifference curves, before I get too far into it on Monday, is that an indifference curve pretty much captures any combination of X1 and X2 where the consumer is indifferent, right, between them. So for a consumer, this point right here is equally good as this point right here, right? Which is equally good as this point right here. And so obviously, if this point, right, is just as good as this point, you would want to be on this point because it's going to cost you less money, right? You're going to be able to afford this point, but not afford this point. Hopefully you guys can kind of see that just based on where it's located with respect to the budget constraint. Okay? Now, what you guys probably don't know yet, and this is totally fair if you guys are confused here, when we find these optimizing points, when we have strictly convex indifference curves, that's going to mean that something, right, which we called our MRS, which is our marginal rate of substitution, and I willingly kind of left that out of question 1. This point right here is the point where our MRS is equal to our price ratio, right? There's like a bunch of calculus that maybe is in your slides that kind of answers why this is. But it's basically just saying that the ratio, right, of my MRS is equal to my price ratio when I'm optimizing, okay? Which is what this person did. Now, if I'm going to offer him 3 units of good 2 for 1 unit of good 1, right, you have to kind of think about, well, what's my price ratio right here? So my price ratio is just 6/3, as we kind of covered, right? So this is equal to 2. Now, if I'm going to offer him 3 for 1, right, that means that you kind of have to think about, well, what was my MRS, right? Because, and I guess I'll kind of go into this, but MRS, in short, is the ratio of the marginal utility of good 1 over the marginal utility of good 2. And so what I mean by this is the marginal utility of good 1, right, is how much 1 additional unit of good 1 affects my total utility. And the marginal utility of good 2 is how much 1 additional unit of good 2 affects my utility, right? And so when we find this ratio, we kind of what we're doing right there is we're finding the ratio of, right, how my utility is affected, right, when we interchange between x1 and good 2, right? Because we're going to have to make those trade-offs. And so we want to be at a point, right, where the trade-offs are in, I guess, our favor, right? And so, you know, that's kind of like a shorthand explanation. I promise I'll cover more on Monday. But essentially what this means is that this ratio has to equal 2 if we're at this point right here, which means that in this scenario, the marginal utility of good 1 is twice as much as the marginal utility of good 2, right? And so if I'm offering 3 units of good 2 for 1 unit of good 1, right? Well, this person values good 1 twice as much as he values 1 unit of good 2. However, right, I'm now going to offer him 3 units of good 2 for 1 unit of good 1. And so this is going to be more than double, right? So in this scenario, right, if I had offered 2 units of good 2, this consumer would have been like, I mean, sure, I guess I'll do this. It doesn't really get me anywhere. But because I'm offering 3 units of good 2 for 1 unit of good 1, or for 1 unit, sorry, this is a typo, for 1 unit of good 1, now this person is going to be willing to make this exchange, right? You can also kind of think about this as being 2 marginal utility over 1 marginal utility, right? And so if 1 unit of good 2 provides 1 unit of utility, then my utility effectively is going up 3, right? And I'm only losing 2 units of utility. That's like kind of, I made that kind of complicated because I think that it's maybe a little bit tough to explain a concept that I haven't gone over necessarily, but are there any questions about this? About why this person is willing to make this exchange? So no, price is involved, to answer your question, Aylin. So the price is involved in our price ratio, okay? So because of the fact that this person was optimizing at this point right here, we know that my MRS is equal to my price ratio, right? And that's kind of like a nuanced topic that you'll for sure be learning a little bit in the future. So essentially, price is really important, right? And we want the ratio of our marginal utilities to be set equal to the price ratio. So that's kind of my reasoning as to why, or my explanation as to why price is important. Yeah, so Sienna, to answer your question, and that's totally fair. So in this scenario, right, we know that my MRS is equal to 2, right? That's just kind of something that is a direct result of my price ratio being equal to 2, right? And so when my MRS is equal to 2, that means that 1 unit of X1 provides 2 units, right, of utility, right? And utility is something that's good. You want utility. And 1 unit of X2 only provides 1 unit of utility, right? And in combination, right, this is going to be equal to 2. Now, the reason why this person is going to be willing to make this trade, right, is because if you think about, right, this person is going to receive 3 units of good 2, which means that utility goes up by 3, right, as a result of receiving 3 units of good 2. And when they give up 1 unit of X1, they're losing 2 utility, right? So their utility is actually going to go down by 2. But the net result, right, is utility going up by 1, right, as a result of this trade. And yeah, to kind of answer, or to kind of add on to what Saja just said in the chat, I wouldn't panic if you don't understand this. Ideally I wouldn't have even gone over this because I don't think that you're necessarily needing to be kind of familiar with all this information. It's just that I have like an extra hour of time that I need to fill with something, and I figured I'll just do practice problems. But hopefully you guys are kind of seeing what I've done here, and it's starting to make a little bit of sense, right? The concept of marginal utilities is so important, guys. And so I guess to kind of just reiterate what I just said, good 1 provides 2 units of utility. Good 2 provides 1 unit of utility. I'm receiving 3 units of utility and only giving up 2 units of utility, right? So that's kind of like the end results that I'm trying to get at. But yes, so that's how I would do this problem. And I'm sure that by next week this would be something that is totally easy to you guys. Just don't freak out if you don't understand it. So we have about five minutes left. So I'm gonna kind of just keep moving on. I think number 3 is something that should be a lot easier. And I'm actually gonna leave it to you guys to answer it in the chat. If my preferences are monotonic, meaning more is better, do I prefer 3 apples to 2 bananas? And I'll give you guys maybe 15 seconds to answer that question. Just drop it down in the chat. Okay, it's been about 15 seconds. And I'm seeing a lot of yeses, right? And so the answer is not necessarily. Okay, so you guys are all like a little bit, you guys have the right idea, but it's a little bit kind of tricky because you're making this comparison between apples and I guess oranges, right? Is that the other? Oh, bananas, right? You're making this comparison between apples and bananas, and you don't know how you value apples relative to bananas, right? So kind of like this whole X1, X2 scenario where they provided different levels of utility. It's possible that you like bananas twice as much as apples, and so having 2 bananas is actually better than having 3 apples, right? You just don't know because they're 2 different goods, right? And so this is like a classic multiple choice question where they try to trick you with maybe the wording of it, right? But you have to be familiar that monotonicity, right, refers to two goods that are in the exact same category, right? So if I had said are 3 apples preferred to 2 apples, then yes, obviously 3 apples is better because of monotonicity, but you can't kind of extend that to 2 different goods. Hopefully you guys can kind of pick up what I'm putting down.
So for a question like this, would you just say it's based off of your preference?
Yeah,
Like,
it's based off of your preference. And I mean, in this scenario, you're not really even having to explain it or anything. It'll probably just say, like, yes, no, I don't know. And like the correct choice is I don't know because you don't have enough information to answer this question.
Okay.
So yeah, Mark, to answer your question, if you like them both equally, then 3 apples are going to be preferred, right? And that's going to be covered next week when we talk about perfect substitutes. But yes, no, I like kind of where you're thinking with that. And so let's just quickly finish number 3, and we might be able to get to number 4. Actually, it's 150. But to kind of just breeze through 3B, a monotonic utility function in apples and bananas. So U, A, B would just be equal to A plus B, right? Where if you keep increasing the number of apples or the number of bananas, your utility is going to go up, right? Meaning that more is better in this case, right? So this is just an example. It could also be equal to A times B, right? Basically something where as long as A and B keep increasing, my utility keeps increasing, then that's going to be a monotonic utility function, right? And so to kind of answer your, or I guess this doesn't directly answer your question, Mark, but say that I prefer 2 apples to 3 bananas, right? And this is kind of a scenario that I brought up when explaining why you can't necessarily know. So a scenario in which I prefer, in which I prefer 2 apples to 3 bananas would be 2A plus B, right? Meaning that 1 apple provides 2 units of utility and 1 banana only provides 1. And so in this case, having 2 bananas or two apples, right? So 2 apples is equal to 4, and 3 bananas is equal to 3, right? And so you would obviously rather have 4 over 3. And the last thing that I want to cover is just this question 4. It has to do with marginal utility. And the question is, what is the optimal consumption bundle? And I want you guys to just quickly type in what the optimal consumption bundle is. And then that'll probably be the last question that we answer. Yeah, Aaron, either one works to answer your question. So think about what the optimal bundle is going to be, right? And when you're doing so, I want you to kind of think about how does increasing x1 or how does increasing x2 affect my total utility? Or I guess it's x and y. So when I increase x and when I increase y, what happens to my utility? And you guys maybe, if I'm not sure if you've learned this so far, but essentially what this question is trying to get at is, am I better off having more of x and having more of y? Or so Mark, to answer your question, this is a case in which you actually don't want to maximize your utility within the budget constraint, right? This is a case where having the bundle 0, 0 actually provides you with the highest amount of utility possible, right? So you can't have negative values within your bundle. You can't have like a negative value of x or a negative value of y. And so when you think about what this utility function looks like, right? This utility function is negative 3x minus 7y. If I increase my level of x by 1 unit, I'm actually getting 3 less utility, right? I'm losing 3 units of utility. And same thing for y, I'm losing 7 if I increase my consumption of y. And so the best that we can actually do is having 0 of each good, right? So the bundle 0, 0 provides you with 0 utility, but that's better than having, say, 1, 1, in which you would have negative 10 utility, right? And kind of so forth with that. But yeah, that's like a good question because it tests your knowledge about how goods affect your utility just in general, right? And something that could be like that is like pollution. It could be like I don't know, like a cockroach infestation. I'm trying to think of stuff that's bad. Maybe like a sardine smoothie. Anyways, but yeah, just basically stuff that is generally regarded as not being good. That would kind of extend towards this concept of negative marginal utility. But yeah, I went over time. I'm gonna try not to do this, but in most cases, but there was stuff that I had to kind of cover, and I didn't get to all of it. I would definitely, once you've kind of gotten the knowledge about what preferences are and utility, I would definitely recommend going back to that info or going back to that extra problem set because I think it is really good. Also keep in mind that I have drop-in hours directly after this time, so it actually starts at 2. It's in a different, I believe it's a different Zoom link, although I'm not too sure. I would probably just use a different Zoom link. So maybe I'll see you there, maybe I won't, but yeah, I'll I'll have my next meeting. Actually, I have drop in tomorrow also. I'm not really sure what my schedule is. You guys can find that all on Gaucho Space. I know that I for sure have my next group on Monday. But yeah, so no worries. Have a nice day. Have a nice week. And have a nice weekend.
Eric, I just had one question.
Yeah, what's up, Aaron?
On the tiered pricing, so the reason it has the kink is because that's like the equilibrium point. If you bought like the cheaper version of the like it was like buy
Yeah. So I don't want
four of
you,
X1 for
you
$5.
you shouldn't necessarily think about it as like an equilibrium point, right? Because that would imply that that's like the optimal point, right? Which it doesn't necessarily need to be. It kind of just represents a point where the price changes, right? That's kind of all I want you to like to really think about is it's just that point in which you get a change in price. Does that make sense?
Okay. Oh, it's just okay. Yeah, the point where it would change from the where the price changes.
Yeah, where it goes from, in my example, where it goes from $5 to $10.
Okay. Yeah, that makes sense. So
Yeah.
you would just do it at wherever, like if it was the first five, that's where you would put the kink.
Exactly. That's where you would.
Put kink at where price changes.
Exactly. So you want to find your two different axes, and then you want to find the point where the price changes. That's going to be your third point, which is the kink point.
Okay, sweet. Thank you.
All right. Yeah. And then for those of you who also have questions, either ask it real quickly or I have drop in at 2, so you guys can just see me there.